let's review some slopes. So this first is called a four-square. So usually we use four squares when we like to review a certain concept and view it from different viewpoints. So plot the points and connect with a line. Count the slope. So if I were to plot 2, -6 with my x is 2 and my y is -6, I would start at my origin and I would go to the right 2, 1, 2, and then I would shift down or translate down 6. 1, 2, 3, 4, 5, 6. Looks like it's right there. Let me just double check. 1, 2, 3, 4, 5, 6. All right, now I'm going to plot my other point, 4, -7. So I'm going to go in the direction, right direction 4, 1, 2, 3, 4, and then down 7. I'm going to shift right down here, but 2 more, correct? Not 2 more, 1 more. I'm over 2 and down 1 more. All right, so if I were to count my slope, let's start here and let's go up. How far do I have to go up to get to the next point? 1, and how far do I have to go over? 2. So my slope is up 1 over 2. In the negative direction. So I could keep doing that, right? Up 1 over 2. There's another point. Up 1 over 2. Up 1 over 2. Kind of looks like a staircase, right? Up 1 over 2. There's my line. Change the color. Perfect. Okay, so next it asks me to find the slope using the formula. What is the formula for slope? That slope-intercept form. What are we comparing in slope? There we go. Good job, Brenda. The change in y, or delta y, compared to, actually I wanted to do that one in red. So the change in y compared to the change in x. So, I want to ask you guys a question here. Our next step was to do that skeleton. Remember how we did that on Friday? Okay, I'm going to ask you guys, and I want you to be completely truthful with me. So, some of the other teachers, so how did I teach you how to do it? Let's do it how I taught you. Go to the Y's backwards. So kind of like untying a knot, just like I've been teaching you guys about knots. What's the last thing we wrote in this sequence? What's the last thing I wrote? If I were to write 2, -6 and 4, -7, what would be the last thing I wrote? -7, correct? So to untie that knot, my Y's are -7 and -6, -7, -6, and my X's are 4 and 2. 4 and 2. That's what I taught you how to do on Friday, correct? Is it easier to do this? 2 and -6 is my first point. My y goes on top, so I'm going to put the -6 here and the 2 here. And this is my second point, so I put -7 on top and 4 in the bottom. Well, that way you just don't have to think about which one comes first and which one comes second. You just put this one kind of like taking a picture of it and, I don't know, taking a picture of it and rotating it. Put the -6 on top and the 2 on the bottom. No? You like it the other way?
Yeah.
Raise your hand. Who likes it the way I showed it on Friday? Who would rather me do it this way? Okay, that answers my question. When I heard that, I thought that was a lot easier. But you guys like it the way I showed you already. So we'll keep with that. All right, so my y's are -7 and -6, and my x's are 4 and 2. I have the opposite of an opposite. What is the opposite of an opposite? A positive. Meant for that to be black. Awesome. So, if I were to evaluate this or simplify it, I have opposite signs, different signs, so I find the difference, right? Different signs mean I find the difference. What's the difference between 7 and 6? Class, what's the difference between 7 and 6? 1, and it's negative because there are more negatives than there are positives, correct? What's the difference between 4 and 2? 2. Is my slope the same as this one? It is, right? Both -1/2. All right, so since we've double-checked what our slope is, write the equation of the line in slope-intercept form. So Levi, what's slope-intercept form? Y equals mx plus b. Well, we know what m is. What's m? -1/2. And I know my b. Do I know my b? What does b stand for? The y-intercept. Well, where am I going to find that at? Right on that y-axis, right? That's the y-axis. If I go down the y-axis, where does it intercept my graph? Oh, right there at -5. So let's write that. Y equals -1/2 x minus 5. That's pretty easy, right? We've got all that information. All right, lastly, let's talk about, explain how this line compares to a parent graph. So a parent graph, I'm going to draw my parent graph in black here. We talked about the parent graph. It's up 1 over 1, up 1 over 1. When y is 1, x is 1. When y is 2, x is 2, right? How is this new line that I've drawn different from my parent graph? It's different in 3 ways. Elijah, what do you think? Okay, first of all, you said the negative slope. So I'm going to reflect my line across the y-axis. Check that out. That was my first transformation, right? What else happened? Slope's now negative. Somebody new? Yeah? It's less steep. By how much? By half. It's less steep by half. We cut our slope in half, so I could take my slope of that parent graph and make it less steep by half. What else? Yes. Good. And we're going to use our translated. Good job. It translated by -5 units. It went shifted down 5. Oh, I didn't do my slope quite well enough, did I? There we go. Questions? So that kind of puts everything we've learned about slope together, right? Why don't you guys copy that down? I'm going to give you your worksheet. All right, so let's begin with another example. So if I have 4, 3, my x value is 4, and my y value is 3. Just joking. Should have been in red. So I'm going to go over 4. 1, 2, 3, 4, and up 3. 1, 2, 3. And then I'm going to go -4, -3. So I'm going to go in the negative direction, 1, 2, 3, 4, and then I'm going to go in the negative direction again, 1, 2, 3. Okay, before I draw my line, let's just talk about this conceptually. If you were just to think about the number line, if you were to just to think about the number line, but a horizontal number line, how far is this point away from 0? Horizontal, sorry, vertical. We're talking vertical. Thank you for correcting me. If we're talking a vertical line, how far away from 0 is that point right there? It's 3 away, right?
Yeah.
And how far is this point away? Also 3? So what's the total distance between the two of them?
6.
Right? Without even counting, I could do that. I technically am counting, but not really. But I'm visualizing it, right? Let's visualize it on the x-axis, the horizon. How far away is this point?
3.
No.
4.
Look at your points. It's 4 over. And how far is this one over? So what's the distance between 4 and 4?
4. 8. 3/4.
Which would be
2.
3/4, right? Let's double check. If I rise up 3 and run 4, let's see what happens. 1, 2, 3, 1, 2, 3, 4. There's a point. 1, 2, 3, 1, 2, 3, 4. Did that work?
Yeah.
It did. You don't have to do it that way, but I want you to visualize it, right? You need to do all of it. There's a reason that you do all of it, Philip. Because if you do all of it, then you're double checking. Then you know for sure, right? All right, let's use the slope formula. What is the slope formula again? What are we measuring?
The change in y over the change in x.
The change in y over the change, oops, I wanted my y's to be red. Delta y, good. Delta y over delta x. Delta. Yes, it is. Okay. So again, I need my what? I need my skeleton. It's funny, students can be so stubborn about drawing it. Guess which students don't get these right? The ones that don't want to do the skeleton. It's an empty frame, right? We're going to fill it in, right? Okay, so I'm going to fill in my y's first. I've got -3, that's the last one I ended up with, right? We're going to go backwards. -3 and 3, -3 and 3, and then what are my x's? -4 and 4. Which gives me, they have the same sign, so what's my phrase? Same sign, so... No, not flip. See, this is why, you guys.
Make a pause.
Same sign means we combine, remember? Same sign, combine. So I have a -3 and a -3 makes a -6. Uh-oh. That's a +6. Why is that okay?
It'll be over -8.
There you go. All right, so I also have the same sign here, so I'm going to combine. So it's a -8, and an opposite over an opposite is positive, which is 3/4. Good job, guys. Good job, good job. All right, so let's write it in slope-intercept form. Aaron, can you tell me what slope-intercept form is? Y equals, you remember? Starts with an M. Good job. MX plus B. Aaron, pick somebody. What's our slope? Okay, Philip.
No, our slope. Oh.
What's our slope? 3/4. Good. Pick somebody. Eduardo, what's my y-intercept? Eduardo. Not Philip. I can hear you, Philip. Just let you know. Eduardo, what's our y-intercept? Here's the y-axis. Good. 0. All right, so let's substitute. Y equals, what goes here? Eduardo, what goes here for M?
Oh, that's
3/4 x. Do I need B?
No.
I don't need B because it's just 0. Do I normally write plus 0? Don't need it, right? I would not mark you down if you put plus 0. All right, let's talk about this line. Raise your hand if you can tell me what different transformations happen to our line. Let's see. Let's write our parent line first. There it is, right there. Nope, Philip, you've already talked. Why don't you pick somebody else that hasn't said anything? Johnny, what happened from my parent graph? What type of transformation happened? Less steep. Johnny, can you tell me, this is kind of a hard question. It's a little bit abstract. Can you tell me by how much? Okay. You think, huh? Because it says 3/4? Philip's already got it. He wasn't supposed to say it that quickly. You guys were supposed to be able to think about it for a second. Why? Explain why.
Because 4/4 minus 3/4 is 1/4, so it's a parent graph already full.
Excellent. That means you must understand what you're doing. Okay, so if this is my parent graph, everybody watch, eyes up here. So here's my parent graph. It's going to rotate by 1/4 to give it a slope of 3/4, right? It's really easy when it's less steep by 1/2 because it just had to move 1/2 to get to 1/2, right? So it just had to move just a little bit, just a little tiny bit. Okay, so it's less steep by 1/4. That's the only thing that happened to it. That was the only transformation, just a slight rotation, right? Still positive slope. It didn't translate up or down on the y-axis, right? All right, good job. Why don't you guys go ahead and try the rest of them. Why don't you work for about 15 minutes, and then we'll get started on our review packet. Okay, so what did you guys learn today? Kind of how to put it all together, right? Slope. When counting slope, which direction does Mrs. Muller go first? No, when counting. On a graph. Oh. All right, guys, I need your attention. Which direction do I go first when I'm counting slope on a graph? I always go up. Then how do I decide which way to go, left or right? Elijah, how do I decide whether to go right or left? If it's a negative or a positive. All right, the person next to you is absent. How would you explain the different ways to place the coordinates when calculating slope? We talked about that today. Remember we kind of voted on it? Oh, the skeleton. The skeleton. Okay, so what about the skeleton? Just tell the skeleton. That's not enough. Let's go back to it. So we talked about whether or not you guys want to put y and y and then x and x, right? Or whether you want to take the point and actually put it inside of the skeleton. How would you explain that? Levi? Up here. How would you explain to somebody if they were absent, how would you explain to them how you decide what numbers go inside of here? Inside our skeleton. Hold on, I'm asking you back. Start with the last thing we said and take that first. Perfect. Good. Start with the last thing that we said. So if you were to write down your point, 2, -6 and 4, -7, the last thing that we wrote was -7, right? So what was the analogy I used, Levi? Untying a rope? Good, untying a rope, untying knots, right? The last thing we did was we wrote down -7, so that's the first thing we're going to untie. What was the last thing on there? Okay, on your assignment sheet, let's do our closing 5. The change in y always goes in the blank. The change in y always goes in the, Brenda, what do we call the cross? The numerator, good job. And the change in x always goes in the denominator. That's your closing thought. Yes. Are you sure? Yeah. All right, good job, guys.
No, don't change it. No.
I won't. I'm just going to stop my recording.
Oh.